Find the length of course BC in feet. In this problem, points A, B, and C form a closed traverse. Survey data provides the measured distances of each course in feet, as well as the 3 azimuth values in degrees, minutes, seconds. In this problem, we have to check to see if the traverse closes. If not, we'll use the compass rule to adjust the latitudes and departures by assuming the linear error is proportional to the length of each side in the traverse. The length of course BC equals the square root of the latitude of course BC squared plus the departure of course BC squared. In plane surveying, the latitude of a course is the north-south distance covered when traversing from the beginning of the course to the end, where a northward direction is a positive latitude and a southward direction is a negative latitude. The departure of a course is the east-west distance covered when traversing from the beginning of the course to the end, where an eastward direction is a positive departure and a westward direction is negative. Next, we'll add a subscript f to our equation to indicate we're looking for the final length, the final latitude, and the final departure after adjustment. The final latitude equals the initial latitude plus the change in latitude caused by the adjustment. The final departure equals the initial departure plus the change in departure caused by adjustment. Next, we'll solve for the initial latitude and initial departure. The initial latitude of course BC equals the measured distance of course BC times the cosine of the azimuth. And the initial departure of course BC equals the measured distance of course BC times the sine of the azimuth. After plugging in the measured distance in azimuth for course BC, the initial latitude equals 909.18 feet, and the initial departure equals negative 1,622.91 feet. Using the compass rule, the change in latitude and the change in departure for course BC equals the negative error of closure for that direction times the length of course BC divided by the total course length. In these equations, we already know the length of course BC equals 1,860.23 feet. And the total length of the traverse is calculated to be 4,040.07 feet. The error in closure for the latitude equals the sum of the initial latitude measurements for all courses in the closed traverse, and the error in closure for the departure equals the sum of the initial departure measurements for all courses in the closed traverse. Next, we'll determine these initial latitude and departure values. As mentioned before, the latitude of a course equals the length of the course times the cosine of its azimuth. This makes the error in latitude equal to negative 0.126 feet, which will round to negative 0.13 feet. The departure values are computed the same way, except they use the sine of the azimuth value, not the cosine. And the error in departure equals 0.323 feet, which will round to 0.32 feet. Now we can plug in these two error of closure values into our equation for the adjustment in latitude and departure for course BC. After plugging in the length values, we learn course BC should be adjusted so its latitude is 0.06 feet further north and its departure is 0.15 feet further west. Next, we'll plug in these length measurements into our equation for the final length of course BC, as well as the initial latitude and departure, and the final length of course BC equals 1,860.39 feet. When reviewing the possible solutions, the answer is D.